Hi everyone. I want to do a quick video, hopefully a quick video, for assignment 3. Sorry, assignment 5. I'm getting ahead of myself. Ooh, nice. So we're looking at conditionals. That would be things like if statements, switches, ternary expressions. Things that tell the program which way to go. Like, if this is the case, then do this. These sort of switch conditions. Ultimately, that's one of the big powerful things that a programming language gives you. It's what makes it more powerful than, say, HTML, which is just a markup language. It's just a bunch of tagged text. This thing allows you to branch or do things depending on certain conditions so that the program can adapt to whatever the data is. So what we're going to be doing is breaking it into a bunch of different parts. And here is my code, but it's only the main method. So in case you think I'm giving away answers, no, I'm not, hopefully. We are going to put in a bunch of prototypes. These are, here's my Super Bowl conversion small, Super Bowl conversion convert large. This will give me two parts of any given Super Bowl number. So if it's Super Bowl 55, which is the most recent one, then it would be LV. I only know this because I saw it on Sunday. So you pass in a number, and so what this thing would take in is Super Bowl small would take in a 5, and Super Bowl large is going to be taking in a 50. And so by doing that, we get LV 55. You can generate what a Super Bowl number looks like by doing this approach. And then we have this function that I'm giving to you, so called Super Bowl printer, which all it does is it calls those other two functions, calculates what the Super Bowl characters are, and outputs a message about that. Notice there's something weird here that we haven't seen before. We're not even going to be discussing it right now. This is the final question for the homework. That is a string. It is anything with text around it. Me not doing this as a pretending to be text. No, I mean literally things with quote, double quotes around them. Not single quotes, double quotes. Double quotes tell me that it is a whole bunch of characters one after the other. Single quotes tell me it's a single character. Double quotes say it's a bunch of characters in a row. It could be one character, it could be a whole bunch, but it's a bunch of characters in a row. We're going to look at that later on in the term, but for the time being, you just need to put in things in double quotes. Good enough. It'll work. Don't get smart. Don't try and put single quotes, double quotes. What other functions do we have? We have simple round, which is a function we've looked at before in assignment 4, but we're just going to do a new flavor of it. That way we can do simple rounding, this sort of simple round function, and we don't have to worry about the kind of fancy math that we were doing last time. On top of that, you can test the round function from the math library, and here is the math library up here. You could test the round function of the math library to see that your round function actually works as you expect it to, which is quite nice. Then we have so my absolute value, so it taken some kind of double. It's going to return some kind of double, so it could be negative 3.972, and it's going to be 3.972 being returned. So it will be, if it's already positive, it stays positive. It's the same number. If it's negative, it becomes a positive number. So any number, no matter what, it's the positive version of that number. It is the distance from 0 is actually essentially what an absolute value is, if you want to think of it. It's the math concept of absolute value. It is some number that is exclusively positive. So negative 4 becomes 4. So, and then we have a couple other weird functions. And some of these you may, if you are cheating and being Narduel and a rogue and a rapscallion, if you are not doing what I'm expecting you to, and if you're looking at previous term solutions, you might see some of these things. That's why they're not worth very many points. The actual heavyweight parts of the code are in other parts of other questions, or I may have changed some of the questions. The point being that the bulk of the points for the assignment are not from the stuff you can cheat off of. They're from stuff you would have to do new. And if you cheat off the other stuff, then you're really screwed because you don't know how to do the new stuff. Anyways, so is exact change is from a previous term? Fine. It's you pass in the number of pennies. So if it's $5 that I want to represent, it's 500 pennies. It could be 501 pennies. It could be 10 pennies. It could be 200,000 pennies. It can be whatever you want. It's just some positive integer. At the amount something is represented as pennies. That way, if it's, let's say, 6 pennies, so let's say the number is 6, the penny price is 6. That means it's 6 cents to buy the item. Can I represent it with exact change now that I'm in Canada? No, I can't. There's a penny extra, right? $2 or 200 pennies can be represented with exact change. It's what, 2 loonies or a toonie, right? This, on the other hand, number of quarters is, you give me any penny price, let's say 345 pennies, $3.45. And I tell you how many quarters it takes to make up 345 pennies, or $3.45. So that would be 3 times 4, 12. So that's 12 quarters so far. And then there's another quarter in the, before you get to 350, so 1 quarter in the rest. So should be 13 quarters, would be $3.45, or 345 pennies. What I'm showing here is, and this is my code, don't copy it, there's no point to copying it. I have a bunch of tests, so I can either test using an assert statement saying, by the way, if this is wrong, blow up. I'll know if it's wrong or not, right? It doesn't, and this actually gets compiled out when I go to compile it for like a release build. When later on, if you ever released a video game, let's say, and you did release build, there's a release build, then it would just, all that code just gone. But in debug build, the programmer gets to see when things go wrong. That's why we have asserts. So my code will blow up here if any of these statements are true, or false. Sorry, false. If they're true, it's fine. You don't even notice it. Or I could do printf statements. Here would be a bunch of printf statements. So here I am calling the math round function, the math library's round function. I can do that. But here's my function that I wrote called simple round. And I'm just checking to see if round is equal to round. Right? That's a good test. Make sure it does what the other one did. I can call my absolute value, and I can see all these different values here and what I would expect the values to always be. They're always going to be greater than 0. And I can check the exact change for 0 and 123. I'm just manually making up some numbers. 123, is that represented in exact change? No. And so I would say what I expect for the exact change test, right? If 123 pennies are used, exact change is, and this will be false, 0 or false, right? We don't have true and false, we have zeros and ones. 1 being true, 0 being false, but zeros and ones. So, and then we can do that for 5002, and we do that for 5010. And I want to predict what I'm going to be getting for each of those steps. So I'm doing the number of new quarters expected, and then afterwards I might do something with the Super Bowl, right? What would be these various Super Bowl numbers? Can I pass in some Super Bowl number that's not allowed? What does it do? In my case, I think it just returns out double quotes, just an empty string. And then maybe I can test my absolute value, or an absolute value function if I wanted to. Great. That's all you're doing for this. I have a bunch of tests. I write little bits of code at a time. I test my code with a bunch of examples just to make sure it works, move on to the next one. If you do it in that way, it's very methodical, it's relatively quick actually. It's at most 2 hours kind of thing. If you write all your code at once and then try to compile it and see what happens, you'll be days. Maybe not, but it'll be a long time, because you don't want this thing could affect this thing, which could affect this thing, which could affect this thing. I want little tiny pieces of code that I test, make sure it works, and move on. It seems slow. It is radically faster than the other approach. From experience, having done the other approach and cursed at myself for doing it, do it a little bit at a time, one problem at a time. Work on it, move on to the next. Because that's what the assignments are for, getting you the practice you need for how to code and how to think about code. Okay, that's all I really wanted to say here. This is just my solution file, and in my main method, I am calling a whole bunch of these other functions, and I have a whole bunch of these functions written below main, but I have a prototype here, that I can then call over and over and over and over again. I'm not repeating code. I'm not copying and pasting my code. I just call that function 10 times. Easy. It doesn't, once I have that function, it takes nothing to write another test. That's all we're practicing. That's the other thing we're practicing here. Okay, that's all I wanted to say, guys. Thank you very much for listening, and hopefully we'll have another video soon. Thanks.